Hello and welcome back. So last time we finished Pong, our first game in Godot, and already we have one Godot game under our belt, and I believe you're now confident enough to go and start creating something a bit more complex. So we're going to start making a 2D platformer. We will create a Mario clone. So let's go ahead, and here I have opened up Godot, and I'm going to click New Project. I will browse for a directory, and on desktop I will just create a new folder and I will call it side scroller. Okay, the project name will be Mario clone, and I will hit create to create this project. Now Godot is going to load up, and there we go. By default it always sets us to the 3D view, but we're not going to be making a 3D game. So let's go back to the 2D view, because Mario is a 2D game. Okay, let's go ahead and hit Ctrl S to save. Let's first add our node. In 2D games, the default node is going to be the node 2D. Let's click create and just call this maybe world or something. And now we can go ahead and Ctrl S to save the scene as world scene. Okay. Now let's go ahead and actually import our sprite sheet. You should have in your top left corner a button to import this sprite sheet. Basically what sprite sheets are, they are images that contain multiple smaller images. Hit import here and make sure to change the import mode to 2D texture and import. Basically a sprite sheet is a image that contains multiple sprites which we will use to animate our player. I will show you how that looks right now. Let's right click on the world and add a new child node. The first thing we will do with our game is actually create the player character, the player movement. In order to move our player in a game that's going to have enemies and obstacles, we will need to use a kinematic body 2D. You will see when we use this, we will inherit many methods that will allow us to move the character, collide him with different things. You'll see. Let's now add a new child node. This one's going to be the Sprite Node, because our player is a sprite. We need some way to show him to the world. Now I'll click on the Sprite Node and just drag our sprite sheet.tex into the texture field. And here we have our sprite sheet. Now you can see we have multiple images here, and we can't really use this as our player. We can't have this walking around jumping. So what we want to do is, with the sprite node selected, in the inspector tab just scroll downwards, and here you will see vertical frames and horizontal frames. Basically Godot wants to know how many vertical frames and how many horizontal frames this image has, this sprite sheet has, so it can slice it up for us. In our case we only have one vertical frame, but we have, I believe, 20 horizontal frames. So let's go ahead and on H frames type in 20, and now you can see we are reduced to one frame. So this is our character, and here you can see this is the 0th frame of our sprite sheet. If we increase this value, we can see how these frames are changing, and we will use this for movement. But we won't tackle animating in this lecture. In this lecture we will simply move our guy around. So let's select our kinematic body 2D and attach a script to the selected node. I will call this script player.gd. Let's create the script. You see now this script extends the kinematic body 2D. You will see many methods that are going to be useful to us. Now I'm just deleting these comments since we don't need them. And of course in the ready function, the first thing we always want to do is set the process to be true. And now below here we want to get the process function, because most of our code is actually going to be executed in the process function each frame. Okay, so in order to move our character, we're going to need some variables. I have created here a field for variables, and I will now create a field for constants. The first variable that comes to mind is the speed variable, so the speed of our player, the speed at which the player moves. How Mario does movement is when you start moving, the speed will slowly increase, and then it will hit the maximum speed value, and when it hits that speed value, your speed will stay at that value. And if you stop moving, you'll slowly decrease your speed, and then you stop. So that means that we are going to need a constant, which is called, we can call it maximum speed. We don't want to go above this speed. Let's set that to maybe 300 pixels. And since when we move, we are slowly building up speed, and when we stop moving, we are decreasing our speed, we will need some kind of movement multiplier. So let's call that constant. Let's call it multi, for short, movement multiplier. And this can be maybe 600. We will play with this value later when we see what suits us when we actually run the game. So these are the two constants that we will need. So for variables, the speed of our player, and then the velocity of our player. We will also want to have a variable for the let's say facing direction, by default 0, because we want to know in which direction our player is looking. Currently in the right direction. You have noticed that our sprite only has characters facing in the right direction, but we will be able to flip our character to face in the left direction when the time comes. So we'll create a variable called facing direction, so be equal to 0 by default. And let's start actually moving our player around. First up, we want to check for button presses, and when I want to go to my scene, click on the scene here and go to project settings, go to the input map, and here you have the buttons that the input maps that you can use. Maybe you want to use for your movement the UI left and UI right, which are the left and right arrow keys, but I want to create new movement actions because I want to move by pressing the A and the D key. So I'll call this section move left. I will add it. Then I will scroll down. Here I have my move left action. I will click this plus sign, add a key. The key is going to be A. Hit OK. Now I want to add a new action, move right, add a key. The key is going to be D. OK. Close. So now you just simply say if input dot get is action pressed. The action is move left. If it is, that means that our facing direction is -1. So we're facing the left side. If you remember when we built Pong, whenever we're moving to the left, so to the -x, we set the direction or anything to be minus. That's why we set the face direction to be -1. And then if input is action pressed, move right, that means that the facing direction is going to be 1. Okay. Now we want to, depending on our facing direction, we want to increase the speed of our player. So let's go ahead and check if our facing direction isn't 0. So if it's -1 or 1, that means that we are moving. And if we're moving, we want to increase our speed. So speed plus equals our movement multiplier times delta. Okay. And else, if the facing direction is equal to 0, which it is by default, we want the speed to slowly decrease. So minus equal movement multiplier times delta. But the way this is set up, our facing direction will never be 0 if we start moving. So we have to change this. We first check if the left, if A is pressed. If it is, we set facing direction to be -1. Now we want to check else if, elif here. So else if, so if this isn't being, if this statement isn't true, then we check this one. So if we are pressing right, we set the facing direction to be 1. Else, if not, the facing direction will be 0. And now, in this case, if it's 0, we will slowly decrease the speed of our player, which will result in our player slowly stopping. Also, another thing, if let's say we're holding D, if we're holding D, so our player is moving to the right, the facing direction is 1, and the speed of the player is increasing. The speed will never stop increasing, and the player will move super fast, so we have to limit that. And after we calculate the speed, we want to limit it. And it's very easy to limit the speed. We just say speed equals, there's this method called clamp, and basically what it does, it asks for a float value here, you can see. So it first needs a value that we want to clamp, then it asks for the minimum amount of that value, and then the maximum. So the value that we want to clamp is speed. The minimum, of course, minimum speed is going to be 0, and the maximum speed is going to be our maximum speed. There we go. So this will make sure that our speed will always be between 0 and 300. And now that this is done, we simply need to add our velocity. Our velocity is going to be equal to speed times delta and times facing direction. Because facing direction, if we're going to the left, is -1, and if we multiply that with all of this, we get a negative value, which will move our player to the left. And now to move our player, usually we use get node and that set position, but since we're a kinematic body, we can call this function called move. We simply give it a vector 2, and the vector 2 is going to be, the x is going to be velocity, and for the y we just say 0 because we're not moving on the y-axis. Okay, so now if we run this, it'll just confirm our scene as the main scene. Now if I'm holding A, you can see my player is moving to the left. If I'm holding D, it's moving to the right. But if I let go of A, my player stops all of a sudden. Well, that is because back in our script, you can see if we are holding A, we are moving to the left. This is -1. If we're holding D, we're moving to the right. This is 1. If we are holding none of those, facing direction is 0. But down here we multiply with facing direction. So as soon as we let go of one of those buttons, this becomes 0, and when we multiply with 0, the velocity becomes 0. So we have to somehow get around that. The easiest way is to just create another variable, call it movement direction is equal to 0. And then simply here, when the facing direction is different from 0, we can go ahead and set the movement direction to be equal to facing direction. So this will basically remember the last direction that wasn't 0. Okay, so now, and we of course have to change facing direction here to be movement direction. Okay, so basically facing direction is the direction that we are currently facing in, and movement direction is the direction that we were facing in last when we stopped holding the key. So now if we run our game, you can see my player is moving, and when I let go, he slowly stops. But he's kind of sliding now, which I don't like. You don't see that in side-scroller games. That is because the movement multiplier is the same value. So let's go ahead and actually multiply this by maybe 1.5. So we just have a bigger number, so he slows down quicker than he speeds up. There we go, that feels much better. You can of course play with these values as you wish. I personally like how this feels. So thank you very much. This has been a lengthy lecture. I hope you understood everything. I'll see you in the next lecture. Goodbye. Hello and welcome. So last time we created the movement of our character. Now if I run the game, our character will be able to move left and right. And today I thought we should add some jumping. So let's go ahead, go back to our script, close the output, and move up here where we have our constants and variables. We will need a few more variables and we will make some changes. First off, let's go to constants. For jumping, obviously we will need some kind of jump force to know how high we actually want to jump, and that value will of course never change, so let's just create a constant, call it max. Actually, let's call it jump force, set it to maybe, I don't know, these are those values that you have to play around with to know what suits your game best, but I'll just set it to maybe 500 for now. And also we'll need some gravity. Let's create a constant called gravity and set that to maybe 1000. Okay, now we have the speed value here, but we will also need another speed value because we will be moving on the y-axis. So to not get confused, I will rename this speed value to speed x, and the new one will be called speed y, which will also be equal to 0 by default. And I will now just take the speed x and replace it wherever we used speed before. Okay, there we go. Another thing, our move method takes in a vector too, and since we will now be moving on the x and the y, we can change our velocity to be a vector 2. Okay, by default of course 0 0. And down here where we calculated the speed x, we will set velocity.x, and here instead of saying vector 2 and all of this, we can just say velocity. Okay, now that we have everything ready for jumping, let's go ahead and go to Scene, Project Settings, Input Map, and I want to create a new action called Move Jump. You can call your action whatever you wish, and let's now click Add to add that action, and now move down. It should be at the bottom, Move Jump. I will click the plus sign here and click on the key. The key that I want to use is going to be space, but we can also use W. Let's also add another one. Let's add W so that we can jump with space or W. Maybe somebody enjoys jumping on W more than he enjoys jumping on space. So now that this is done, hit close. Go back to our script, and in the process function we want to check if input is action pressed. If the action that is pressed is going to be move jump, we simply want to set our speed y to be equal to jump force. There we go. Also, each frame we want to subtract from speed y gravity, the gravity and gravity times delta, because we are affected by gravity each frame. Now we have to of course set the velocity .y, and that is going to be equal to speed y times delta. Okay, there we go. And now we have just move velocity, and now our velocity holds an x and a y. So let's go ahead and check out to see how our game now looks. And you can see our character is falling. Let's see that again. For some reason I wasn't able to jump. Let's see what that is about. Speed y, jump force. Jump force. Let's increase the jump force here. There we go. Could be that it's too small. I forgot that the y axis in Godot is the positive goes down, negative goes up. So I have to set this to be speed y to be equal to minus jump force in order for us to jump. Okay, let's now check it out. Oops, and there we go. We jumped very high. So let's decrease our jump force to maybe 500. Let's check that out. 500 pixels should be good enough. And there we go, we're jumping. But 500 pixels could be too much. Let's decrease that maybe to 350. And the gravity also feels a bit strong, so let's set it to maybe 800. Let's check that out now. Alright, that feels much better. But of course, we can now jump infinitely. We will limit that, don't worry. Let's now add some colliders so our player doesn't fall down to the ground, through the ground. On our kinematic body 2D, we can add a child node, and the node that we want is going to be a collider, collision shape 2D. So let's just create that. And now it's looking for a shape. In 2D games, I recommend you use rectangles or circles. Those are the best that you can use for 2D games. Let's now select a new rectangle shape, and here we can see our collider. It's off here, but we will just press W and we will be able to move it to our player. We can scale it by dragging on these pins here, and it's usually good practice to have the collider a bit smaller than the actual player. So that looks good enough. But now we also need a collider for the ground. So I'm just going to right click on the world and add a child node. I will add a node 2D. Create. I will call this now node ground, and this node will have a child which is going to be a collision shape 2D. Okay, of course this will also have a rectangle shape. Let me just find it, it's up there. We can increase it, we'll increase this to be very big. There we go. Put it under our player. And for the player to actually be able to collide with this, well, for the engine to be able to calculate the collision for this object, we need to add a child node for this, which is going to be a static body 2D. We already spoke about kinematic bodies. These are for game objects that will move around the scene, but this one won't move, so we'll just add a static body 2D. There we go, create. And now if we run, our player should collide with... sorry, this has to inherit, the collision has to inherit from this object. Let me just move it up. Actually, delete the static body. Ground, add child node. We need a static body. There we go. And just add the collision to the static body, and now our player will collide. You can see he collides. And actually we can click on this antenna here and click visible collision shapes, hit play, and you can see that we now see the collisions. But we can't move our player when he's colliding. That's because of how collisions work. If we jump, gravity pulls us down, and it keeps pulling us down, and so we can't move our player. We can fix that very easily. Go back to our script. In the function process, let me just close the output here. We can use something called, we can use a method called isColliding. So let's say if, check to see if it's colliding. If isColliding, what we want to do, well, we want to do a few things. First of all, we want to take this move velocity, because this ground here has a normal and it's facing above. Each ground has a vector normal that's facing above. We want our player to slide on top of this, but currently he's moving downwards, and if we were to move him to the right, he wouldn't be actually moving to the right, he would be moving diagonally in this direction. So we need to get the remainder of the movement and just add it back to our movement and slide our player on top of this ground. To do that, we can create a variable called, let's say, move remainder, and this is going to be equal to pretty much just our move velocity. And now back here, we want to get the normal that we spoke about earlier. So create a variable called normal. It's going to just get the collision normal of the object that we're colliding with currently. And finally, let's call this variable final move. It's going to be equal to this normal that we got, the collision normal, and we want to slide our movement remainder on top of it. There we go. And also, if we hit the ground, our speed .y, gravity would still be affected and it would still increase. And then if we were to leave the ground, it would just fall super fast. So we don't want that. We want to set speed y to be equal to 0 if we're colliding with anything. And after all is done, we can simply call the move function again. And this time we just move final move, and there we go. So let's check that out now. If I hit play, there we go. I can still move on this. I can now move on this platform. Pretty awesome. Alright, great. Thank you guys for watching. I'll see you in the next lecture. Goodbye. Hello and welcome back. So last time we made sure that our character can jump, and we added some gravity. But now I can jump into infinity if I just keep pressing space. There's no way for us to actually limit the player jump. So in this lecture, what I want to do is make sure that we can't jump to infinity. And I'm also going to play around with the values of our acceleration and deceleration. And we will make sure to flip our sprite. So let's actually go ahead and flip the sprite first, because flipping the sprite is very easy. If we click on our sprite in the scene view, you can see that right now down here in the inspector we have a flip H option, and if we enable that, you can see the sprite is flipped. So we can do that very easily. Let's go to our script. We need to get a we need a variable. Let's call it player sprite. And as soon as the game is ready, in the function ready, we want to get a reference to our sprite. So player sprite is equal to get node sprite. Alright, and now when we move to the left, we simply say player sprite set flip H true, and when we're facing to the right, player sprite set flip H false. Alright, let's check that out. And indeed, our player flips. Great. And now I just want to increase our movement multiplier. So let's set that to maybe 800. And I will increase this here. When we decrease our speed, I will set it to 2. So I want to decrease the speed 2 times as fast as I am increasing it. And now we want to limit the player jump. So as I've said, we can jump infinitely, and we don't want that. So let's go ahead, and to do that, we need of course some variables. Let's go ahead and create a max jump count variable. I'm going to set this to 1 because I want my player to be able to jump only once. But maybe later in the game we can get a upgrade which will increase this variable so we can jump twice. And then I'm now going to create a variable called jump count to keep count of our current jumps. Alright. So here, when we press the jump key, I'm also going to check if jump is pressed and jump count is less than max jump count, we're going to jump. And when we jump, we want to increase our jump count. So jump count plus equals 1. Alright. So now, if I run the game, I should be able to jump only once. Let's see that. And in fact, I was able to jump only once. I'm now hitting the space key, but I'm not jumping. That's because this value is now 1, and it isn't less than max jump count, so this won't execute, but we never restart the jump count. Now you're thinking we should restart the jump count here when we collide with something. Well, you're partly right, but we shouldn't do it just here. We can't just say jump count is equal to 0, because this refers to any collision. So, well, let's just leave it like this. And if I run the game now, everything will work as intended. You'll see I will be able to jump when I hit the ground. But if I now duplicate this ground, let's just duplicate it. Okay, ground, and if I move it, maybe if I rotate it like this and set it here to kind of pretend to be a wall, you'll see now I'm hitting the wall and I'm able to jump upwards. That's because we're colliding with the wall and that code is executing. So we need some kind of way to know if we hit the ground from above. It's very easy to do. We can go to the script, and here this normal. Normals are vectors, as we said earlier, that face upward. So we can simply check to see if this normal is facing upward. So let's go ahead and do that. After we move our character, we can go ahead and check if this normal is equal to vector 2, and if it's facing upwards, that means it's 0 on the x, and on the y it's -1, because in Godot y upwards is -1. So if this normal, let me just add some brackets here. So if this normal that we got from the collision is indeed facing upwards, that means that we can restart our jump count to 0. There we go. If I now run our game, you can see I'm jumping. And if I hug the wall, I cannot jump anymore. Alright, nice. So thank you for watching. In the next lectures, we will add the player animations. Until then, I'll see you, and thank you for watching again. Goodbye. Hello and welcome back. So last time we made sure that our player has a limited jump, and if you like, you can create a double jump by simply changing a variable. Also, what I did off screen is I went to Scene, Project Settings, and went to Display and just changed the width and the height to 640 pixels and 420 pixels, just so the game feels more like an old school platformer. So today we want to actually animate our player, and actually it's going to be very easy, because if we select our sprite here under the kinematic body, which I renamed to player character, we can scroll down and we can see that we have this frame here. Currently it's set to the 0th frame, and the 0th frame is the idle animation, but if we move up, we can see that 1, 2 and 3 are kind of like these movement frames. And then we have 5, which is a jumping frame. And we can just change these values through a script and get cool movement. So that's exactly what we're going to do. Let's move to our script. We already have the player sprite reference, which gets the node sprite, and this sprite node has all of this that we need, which is very convenient. First up, let's go ahead and where we jump. So here, if input is action pressed jump and jump count is less than the max jump count, we can set this frame to be 5, so the jump frame. So let's go ahead and do that. Let's get the player sprite dot get actually set frame, and the number of the frame is going to be 5. And of course we want to reset this frame somewhere, and let's reset it when we collide with the ground. So here I will just say, when we set the jump count to be 0, I will set our sprite, our frame, to be 0 as well. So let's now run the game. And you'll see if I jump, we get the jumping frame, which looks really good. And as soon as I hit the ground, we get the idle animation. And now we want to create some animation for actually running. So we have 3 frames for that, and we're going to loop through them. Let's go ahead and do that. I will close the output so you have a nicer view. And I'm actually going to create a new method and just call that method when needed, so our code looks much better. So let's go ahead and say function, and I'll call this method Animate Player. Animate, okay. And how I'm going to animate him, I'm going to create a variable called delta time. It's going to be set to 0 by default. And delta time, whenever we animate the player, is going to be equal to delta time plus delta. Delta, of course, being the value in the process method. We do this because, actually, we won't do this in this method. So in Animate Player, what I want to do is so we want to move from the first, second, and third. Those are our movement sprites. Let's go to the 2D view. Click on sprite. So 1, 2, and 3 are our movement frames. So that's what we want to loop through. First up, I want to check if the player sprite is greater than get frame. So if the current frame is greater than 3, I want to reset it to players. I want to reset it to player sprite, set frame, reset it to 1. So to start the animation over again. Okay. And here, what we want to do is simply say player sprite, set frame, and the frame that we want to set is going to be the previous one. How do we get the previous frame? We just say player sprite get frame plus 1. So basically, we will, whenever we call animate player, the first thing we'll do, we will check if the current frame is greater than 3. If it is, we will reset it to 1. Actually, let's set it, greater than 3. We will reset it to 1. Else, if this isn't the case, we will just increase the number of our frame. Okay, so where do we actually call this method? Let's scroll down. And here, where we move left and move right, that's where we want to call our animate player. But also, we want to get our delta time is going to be equal to delta time plus delta. And we want to check if delta time is greater than the 10th of 1 second. So if a 10th of a second has passed, we want to call our animate method, animate player method. There we go. And we want to do the same below. So let's just copy this code and add it here. And also, when we animate our player, we want to restart the delta time to 0. We can do that in the animate player method. Let's simply set it to be, let's set it to delta time to be equal to 0. All right. Now this won't work because each frame we are setting, when we are on the ground, we are setting the player sprite to be 0. So let's just comment this out for a moment and run our game to see if everything is working as intended. Alright, now I'm running, and you see, well, our character is also doing the 4th sprite, which we don't want. If I show you now, the 4th sprite is this. So let's go ahead and do that. Let's, when we check the player sprite, just check to see if it's if the player sprite is greater than 3. Let's see if we set greater than 2. There we go, we have this animation. If we jump, we get the jump animation, but we don't have our idle animation anymore because we're just standing here. We just keep the last frame. Don't worry, we're going to fix that. I'm not really sure why, if it's greater than 3, why do we get the 4th frame? Not sure. Let's see. Let's set it if it's equal to 4. Let's see if this will work properly, because we're missing 1 frame of the running animation. 1, 2, 3. Let's see. Sprite frame 1, 2, 3. This is the 4th frame. So we set the frame to be 1. Get frame plus 1. I see what we can do. We can set this frame to be 0, and then we will instantly increase it. I think this will fix our problem. No, not quite. Let's set it to be greater than 3. Not sure why this is happening. This shouldn't be happening, to be honest with you. Alright, let's create another check to be safe. So if player sprite get frame is less than 4, this is going to happen. Okay? Now we should be completely sure that the 4th frame will never show up, but it still shows up. Get frame plus 1. It's less than 3. Yeah, if it's less than 3, we should be able to do this. And there we go. But we still need to restart our frames. Okay. If it's equal to 3, we will restart our frames. Because how this set up, it would never go above 3. Now what? If the current frame is equal to 3, we will restart the player frames. If the player frame is less than 3, we will increase the player frame. What seems to be the problem here? Let's see. When we move left, we increase delta, and if delta is oops, I died. If less than 3. If it's greater than 3, let's see. Why does it stop animating though? Let's say greater than or greater than equal to 3. And there we go. Okay, so those were some really weird issues. I'm not sure why that didn't work in Godot as intended, but now it's working as it should. So now we can see we're walking to the left or walking to the right. If we jump, we get the jumping animation, but we still need to fix hitting the ground. So let's go ahead and do that. Now we can't just have this player set frame here 0 when we're on the ground, because this would be setting each frame. If I now run the game, I'll show you. We're just showing the idle animation, and if we jump, we get the jump. That's because each frame we're setting the 0th frame. So we're actually going to get a variable. I will call it landed. Okay. And when we jump, I will set landed to be false, so we are in the air. And when we are falling, we can go ahead and if landed. When we hit the ground, we can check if landed is false. We want to sprite player sprite set frame, set the 0th frame, and then set landed to be true. All right. So this is how it's going to work. We are going to jump. We will set the landed variable to false, and then when we hit the ground, if landed is false, we will set the frame to be 0, and then we will set landed to true. So this will only execute once. Let's go ahead and try that out. So I can now run. You can see I'm running on the, look at me, I'm running. If I jump, we get the jumping animation, and if we fall, we get the normal frame. Whoops, I again died. Oh, let's look at this. I can run on the ground. If I jump, I get the jump frame. If I fall, I get the falling frame. But there are still a few issues. So if I stop running, I just stay in my last frame. And also if I jump and run, I'm still like animating my running animation. Those are some polishing things that we'll fix in the next lecture, since this one is getting pretty lengthy. Thank you for watching, and I'll see you in the next lecture. Goodbye. Hello guys, and welcome back. So last time we made sure that our player is animated, and we can now run along this plane here. We can also jump, but there are still a few issues. Mainly if I start running and stop, our player just stops at the last frame. You can see the frame is 4, and now also if I jump and move, we are still moving. So we need to fix this. Let's go ahead and actually, if you see this 4th sprite, this is kind of when Mario stops. So I want to use that as well, and this is going to be very easy to fix. So here, where we move our player, when we hold the left key, A, move left, we animate our player. Also, when we hold the right key, we also animate our player. But else, this is when we stop holding any keys. So when we stop moving, I want to set the player sprite to be set frame to be 4. So I believe that's this frame, so kind of him sliding, trying to stop. So when we stop holding any buttons, I want him to show this frame. Now you'll see it's very easy to get the idle frame. We just want to check if the velocity x is equal to 0. So if he's not moving on the x-axis, we simply set the frame to be 0. And now if I test this, you can see I'm running, and I stop running, my player is now on the idle animation. But notice how this feels nice. If I'm running and I stop running, we first get that frame of him trying to stop, kind of like sliding, which feels really awesome. Our game is starting to feel really good. Also, now when we jump, we still have the running animations, but we're going to fix that, no problem. We actually set that up last lecture. If you remember the landed here, simply what we're going to do is only animate our player if landed is true. So here, when we animate the player, I'm going to check if landed, which basically means if landed is true. If it is, we will animate our player. The same for this one. If landed, we will animate our player. So So how this works now, we jump, we set landed to be false, and the player sprite set frame 5 has the priority here. So the frame 5 will be set, and then only when we hit the normal of our ground, we set the jump count to be 0. Landed is still false, we set the sprite to be 0, and we set landed to be true. Then we will be able to animate our player. So let's now test that out and hit play. Okay, I'm running and I jump, and there we have our jumping animation, which looks really awesome. This game is starting to feel really good, but there is still one issue. Did you figure it out? Maybe you did, maybe you didn't. If I jump and don't move in any direction, we're showing the idle frame. Well, that is because here we checked. Let me just find that real quick. We checked if the velocity is here. If velocity x is 0, we set the frame to be 0. But when we jump, we're only moving on the y-axis, so that means that the velocity x is of course 0. So here we can also check and velocity dot y is also 0. If that's the case, set the frame to be 0. Let's go ahead and run our game now. If I, whoops, we're having some issues here. Why is that? Actually, we don't really, we get the 4th frame and velocity y. dy is we can't actually check velocity y because we're always trying to move downwards. So let's figure something else out. We can also check to see if landed is true, and let's just say and landed. There we go. That makes more sense and is easier. But now we're for some reason rendering the 4th frame when we jump, and we don't want that. Let's see why that is. And that is because we're not moving in any direction, and it is setting the frame to be 4. But here we want to check if landed is true, which means that we are grounded. Then we can set this frame. Okay, so let's now run our game. Now when I'm running, I stop, we get that stopping animation, and if I jump, we of course get the jumping sprite, and the jump feels really good. The animations are awesome. Now our game is starting to feel really nice. Let's close the collision shapes and see how it looks without them. And it's looking really good. Feels just like a Mario game. There we go. Our player is now ready, and in the next lectures we'll be building enemies, environments, power-ups. We'll get a power-up that when we pick up increases our size, just like in Mario. But this is amazing progress. The game feels really nice. You should be definitely proud of yourself. You can now play around with the movement, the speeds, the jump to get that feel that you desire. But I think how it is, it's really awesome. Just running around feels really good. And that's how you know that your game is on the right track. Thank you guys for watching, and I'll see you guys in the next lecture. Until then, have a good time. Goodbye. Hello and welcome back. Last time we finished everything regarding the player movement and animations, and I'm very satisfied with our project progress so far. The movement, jumping, and animations are all very smooth, and the game really feels very good. This lecture is going to be, let's say, relaxing, because we're going to be doing a level design. We'll create a level for Mario, and you'll see it's going to be very simple. We'll just import a few assets, and we'll basically just drag images onto the screen and add colliders, and then we will lay the basics of our level. So let's go ahead and I'm going to close the play mode. Also drop the output so we have a bigger view of the screen. And here I have our tileset for the map. The tiles that we will be using, I will drag and drop them into our project. And here we have the import mode. I'm going to import it as a 2D texture. Click import. There we go, now we have our map tileset as a texture. And here on our ground, I will simply add a new child node, which is going to be of type sprite. Drag down, we also have them here recent. So create the sprite. And for the texture, we will drag our map tileset. And let's see where this is. It's over here. I'm just going to drag it here. And you can see here we have, previously on our player we had, I believe, 20 sprites in one row. Here we have 2 sprites in 2 rows. So you know what to do. Vertical frames, we gotta set that to 2. And horizontal frames also 2. There we go. Now we have, this is the 0th frame. The first frame is going to be the one that was next to it. The second is going to be the first one on the second row. And the third frame is going to be, of course, the final one. So let's take actually the second frame and we can start creating our level. This is what we'll do. We'll simply place these blocks here. I will now duplicate this block and place it right next to this one. And then I'm going to hold Control and select both of these sprites, duplicate them as well, and move them next to these. There we go. And then I can select all of these sprites and duplicate them once again and drag them over here. You get where this is going. Very simple. You can, if you wish, you don't need to watch this lecture. We are just going to be creating kind of this level by dragging these sprites. Very simple, very relaxing. Level design should always be very relaxing. Play some music for yourself or whatever. And now we're going to copy them one more time, and then we'll do, let's duplicate them now and move them over here. And there we go. Let me just get this right. Okay, and also I want to just increase my collider. Let's drag that over here. Actually, like that. And there we go. Fits perfectly. And now what I can do, I can just drop down this ground game object, and I can duplicate this node. Let's duplicate that, and I have more ground here. And I'm just going to place it below this ground. So now when I start the game, you see we have this ground that reminds you of Mario. And already the game looks much better and feels better. Let me just move these a bit closer to the top. Closer to these up here. Okay. Let's see how that looks. Alright, looks great. Let's go ahead and we can duplicate. We can select both of these grounds and duplicate them. Let's zoom out and move our ground like that. If you're worried about getting these perfect, we can just, of course, look at the Y position on these nodes and just make sure that it is the same for this one. But I think just looking at this is good enough. And also you gotta make sure that the colliders are properly set up. You see, these are our colliders, so in this case we're missing some shapes. Well, we're going to fix that. Let's zoom out. Get the static body, collision shape, and let's just make sure that it is, there we go, that we have a seamless transition a bit more above. Oops. Alright, let me see how that looks. Alright. Oh, you see, because the collision here is, let me just show you. Where was that? And there we go. You see here, on this spot, the collider is a bit higher than this one, so our player can't walk there. And that's really, we can't have that in our games, so we gotta make sure that that doesn't happen. Let me just lower this collider. And let me select, just find this ground, this node. Yeah, that's that one. Drop it down, collision shape, and drop the collider down a bit. There we go. I think that should fix it. Let's check it out. Still an issue here. No problems. We will fix that. Okay. Always make sure to playtest your games. While you're working, you gotta make sure to test them, that they work. Alright. That seems about right. There we go. Okay. Should be right. Let me see this one here. Alright, seems to be good. Okay, let's test it out once again. Okay, there we go, great. Mario can now run in a straight line, and it feels like he is running on these tiles, where he's actually running on those colliders, but we are creating the illusion of him running on these bricks. And now what I'm going to do off camera, not to take up your time, I'm going to lay out the level from here to finish. You can find a Mario reference level. I will add that as a link after this lecture, where you can, if you want, copy the original level of Super Mario Brothers. If not, you can create your own. But basically, I'm just going to continue building up towards the end here. And when we play the game, we'll just move the camera and move our player to the end of the level. And finally, we have these grounds here. What we can do is just select them and drop them on this one as a child, and everything will still be working as it should. And there we go, we're running. The game feels and looks awesome. So thank you for watching this quick and easy lecture on, well, level design. So next time you will see I'm going to have a finished level. So go ahead and just lay out the ground for your level. You don't need to do anything else. That's exactly what I'm going to do. But I don't want to have a 20-minute lecture of just me placing these images and colliders. So I'm going to do that off camera. And later we will be adding some obstacles to jump over and to hit them, power-ups and enemies, and we will also add logic for the camera to follow the player so that we can actually go outside of the screen. So thank you for watching. That has been my time. I will see you in the next lecture.